All right, let's get into it. Have you ever really stopped to think about what's going on under the hood of your computer? Your phone, your laptop, even those massive supercomputers. They all share the same fundamental DNA. Today, we're going to pull back the curtain and look at the basic blueprint that powers every single digital computer out there. So you look at a computer and you see it doing a million different things, right? It's playing games, it's crunching numbers, it's connecting you with friends. But if you strip away all that complexity, what is its one single most essential job? Well, it turns out to be surprisingly simple, and that's what we're breaking down today. And here's the secret. It doesn't matter if it's a tiny chip in your watch or a server farm filling a warehouse, every digital computer is built around just four, basic functional units. This is the universal blueprint. Once you get these four parts, you fundamentally get how computers work. So here they are, the big four. You've got the input unit, which is how we get stuff in. The storage unit, which is where everything gets held. The central processing unit, or CPU, that's the brains of the operation. And finally, the output unit, which is how the computer talks back to us. It's a beautiful logical flow. So to really understand it, let's start right at the beginning, with the input unit. Okay, so first things first, how does the computer get any information from the outside world? How do we tell it what to do? That's the whole job of the input unit. Think of it as the computer's senses, its eyes and its ears. It's the gateway from our world into the machine's world. The official definition is actually super straightforward. It just performs the inputting operation. It accepts instructions and data. Every single time you type on your keyboard, click your mouse, use a game controller, or even scan a barcode at the store, you're using an input device to talk to this unit. But it's doing more than just listening. It really has three key jobs. First, it accepts her instructions. But second, and this is absolutely crucial, it has to convert what we give it into a form the computer can actually work with. It's like a translator, turning our language into the computer's native tongue of ones and zeros. And finally, it sends that perfectly translated data over to the storage unit, ready for the CPU to work on. So we've given the computer our instructions. It goes off, does its calculations, works its magic, but then what? How do we see the result of all that work? Well, that's where the final piece of our puzzle for today comes in, the output unit. And just like its counterpart, the output unit's job is to perform the outputting operation. It takes the results that the system has produced, but here's the catch. Those results are in a coded form. It's still in that machine language, the ones and zeros, which isn't very useful to us humans. And this is where it really shines. The output unit acts as our translator again, but this time in reverse. It takes the computer's coded answer, converts it back into a human-readable form we can understand, like the words you see on your LED display, a photo from a printer, or even complex architectural drawings from a plotter. Then it supplies that final converted result back to us. I love this slide because it shows the beautiful symmetry of it all. They're a perfect pair. The input unit's job is to translate our human world into the computer's language. The output unit's job is to translate the computer's language back out to us. Together, they form this essential bridge between our world and the world of the machine. So when you look at these two units working together, the gateway in and the gateway out, you really start to see the computer's ultimate purpose. It's not just about shuffling ones and zeros around. It's about a fundamental transformation. This quote from the source material just nails it. It converts these coded results to human-acceptable, readable form. That's the whole point, to take all that complex internal machine logic and make it something that we can actually look at, understand, and use. And that brings us to the most important takeaway of all. At the end of the day, a computer's main job is to turn raw data into useful information. It takes the messy, unstructured stuff we give it through the input unit, and it gives us back structured, meaningful information through the output unit. That transformation is computing. So we've seen the beginning of the journey and the end of the journey. We know how raw data gets in and how useful information comes out. But what about all that magic that happens in between? What are the storage unit and the CPU actually doing in there? Well, that is a fantastic question for our next explainer. Thanks for joining me.